Okay, welcome to our first class, September 11, 2023, Venture College. And the course is called Safety SFTY 1051 Tools and Workplace Techniques 2023 Fall Term. Okay. All right, so now, as soon as you log in to the class portal, most of us have found the way here, and if you haven't, then let me know. Right? Once you log into the class portal, this is the announcement section that is pretty much lives there right away. You're going to see that. And these announcements are liquid type of screen here, which what I mean by that, these are going to change. Like, for example, after these two Zoom sessions announcements, I'm going to erase those so we don't pollute our announcements here. Now, here, I might leave that welcome message. Why not? And over here is where you find all the YouTube material that is associated with our class. Now, when you click on that, I have a separate window I'm just going to call up. That's where you're going to get. Now, this list of videos in that YouTube playlist is going to populate as we go along, right? Now, the first video that is already there, I want you to, after we are done, at your own convenience, I need you to watch that 16-minute video, which talks about how to read an analog display or analog meter. You should know how to use analog meter because sometimes, although the digital multimeters are the newer thing from the analog meters, they seem to be better, but that could be deceiving. Everything has its tolerances, everything has its accuracy definition or well, definition of that. By that I mean accuracy. Okay. Now, this is only so accurate depending on many physical aspects of the analog meter. The digital meter also is going to have so much accuracy. So just because you see numbers on a display doesn't mean this is exact. These numbers are going to be displayed on the digital readout of a multimeter are going to be according to the meter's accuracy, right, and definition of it. Okay. So please watch that video. You need to know how to use digital and analog multimeters because sometimes the analog meter will do stuff that digital can't. And we will talk about that next time we see each other, right? But just go through that. It's a pretty simple video, 16 minutes out of your lifetime. And it's quite beneficial to your knowledge. All right, now I just went back to the main class portal. And I'm just, see here is our class portal right now. Now, welcome message, our YouTube playlist. We go, now here is the class list according to sections. So find out what section you belong to. And based on that, you'll be able to see if you keep scrolling down. Oh, you see here, this is the email that I sent you. Please watch that here because by default, this main class portal is going to show you just so many announcements. And if you want to see all the announcements, just click on that and you're going to see the rest of the announcements. So I just clicked on that and we can keep scrolling down. And here is the lab schedule. So according to the section that you find where your name is, that's the section you belong to. And let's say you belong to section number 4, for example. Right? So that's what you're interested in. Everything else kind of irrelevant, with emphasis on the term kind of. Now, belong to section 1. You're going to just go down and see where your next lab is. Okay, keep going down, keep going down. Oh, there's lab. All right. When is the lab? Well, go left. It's on Wednesday, September 20th. That's going to be your first lab. That's your first time I'm going to see you in the lab. All right. Now, section 3 is going to be September 13th, Wednesday. And the times are listed, 5 to 7 p.m. Section 1, Friday. See, that's lab 1, and so on. So all the labs are listed right to the end of the school term by date and by section. You should have no problem finding that out. Okay. Now, there's two couple of like orange marked sessions for section 2 and for section 6. October 5th here and October 6th, there's no school, but that's where your labs come up to be. So there are a couple of ways we can tackle this. You can join any section, any other section. Now, let me know that you're joining because we can only fit so many people. So, between now and the end of the term, we should be able to have enough sessions that some people can join in and just perform that lab. All right. Or if you finish lab 1 quick enough, and lab 1 and lab 2 are very similar to each other, you can still have time to do the lab 2 during that time, if that's the case, right? Or the third option, you can do this thing during the open lab session. And if you still are not able to do any of those, I will maybe create a like little extra session so we could have you have the opportunity, fair opportunity to perform these 2 labs. Okay. Now, once we go there here, so go back to the main class portal, and I'm going to point this tab right here, which is content. If you click on that, I'm clicking on it now. What do you see here? You see on the left is like a navigation type of a section here. Click on the course outline, and you're going to see those 2 documents. One is the course outline, so it's like more generic information about the course. And the second document is our course plan. This is our roadmap to success, kids. All right, so you can download this thing if you want as well, or you can just look at it while being in FOL. If you download, that's what it looks like here. It's magnified version. There's the course information and so on and so on. This course might da. I organize it this way. Other professors might organize it slightly in a different way. This is how I do it. Okay, so here's the list of the labs, the titles, and the weeks that they're going to be performed in. And here's the course content as far as the course weight. So all the labs combined are worth 50% of the course. Right? Quiz, we have 2 quizzes, quiz 1 and quiz 2, each worth 5% of the whole course weight. Then we have assignment, which is going to be worth 10% of the whole course. And then the test 1 and test 2, each are going to be worth 15% of the whole course. And if you just add the whole thing up, of course, it has to add to 100%. Right? There's no any other possibility. Excuse me. All right, there's some additional information here as far as midterm grading is going to be provided by Friday, October 20th, and the final grades have to be entered by me by December 19th, Tuesday. All right. Now, important information here. In order to pass this course, this has to be said. Okay. In order to pass this course, all labs must be attended, performed, and evaluated with all combined average of passing grade, and passing grade is 50% minimum. Now, here's the thing. All labs must be attended, performed, and evaluated, which means, again, I'm going to say that if your whole average combined of all the labs is like, you could have it like 75 or 80% or whatnot, but you haven't done one lab, you still fail the course, right? Pretty mean, right? And here's that and in red. And separately out of that, from that, the average evaluation for combined test quizzes and the assignment, this is the theory part, theory, must also reach a passing grade, which is 50% minimum. Right? I can't say enough of that because, well, we just need to make sure that everybody understands this concept right here. Labs are bi-weekly and they're according to that schedule that I just showed you. And detailed schedule, it is already posted. I just showed you that a couple minutes ago. Right? Now, if you keep scrolling down in the course plan, you're going to see the roadmap. Week 1, we already done that. Week 2, okay, see, I just put the span of the dates from September 11th, September 15th. So week 2 spans over Monday and Friday. So this is Monday, this is Friday. So that's where the week begins, week ends. And your lesson is going to be according to what your schedule is within that week. So right now is the first online session that we have, and this is the first part of the multimeters that we're going to cover. Here's week 3, week 4, and so on, and there's some additional information that I thought would be valuable. And of course, the same thing with the tests, how much they're worth. It's the same table that right here, okay? And we are going to try to follow as best as possible. However, sometimes this thing might change depending on circumstances. Like, for example, there could be a snowstorm or whatever else. Then somehow we're going to have to shift things, but everything is going to be covered. Okay. And the final grades, of course, by September 11. All right, so here is the roadmap to success. If you want to know which week we are in, just call up my course plan and you'll be able to tell which week we are in right now. This is how I set things up. All right. So this is as far as that. Now, again, I'm going to go back to the main class portal. And again, I'm going to, if you click on the content, here is your student items. That's where I'm going to click on that. Just treat this left portion of the screen as your navigation type of a section. And over here is the content. I'm going to collapse all the folders. So we can expand the folder and collapse the folder. And I have divided this. I might add some things as we go along, but this is the basic right now. I have divided this thing in the theory, post-it notes, and the labs. Okay, so click on that here. This thing comes up. In the theory, you already have some post-it notes. Week 1 tools list. Get those tools. Right? That's what we need for this course. Now, here's an information on the personal protective equipment, PPE, which explains what we need for the hard hat, food protection, and eye protection. Hard hat type 1 is fine. Type 1 is the lower grade of type 2. Type 2 is much heavier, so we don't need type 2 in our class. Type 1 is fine as far as hard hat. It has to be E-rated. Okay, we're going to go over that a little bit in a second. And foot and eye protection. So all explained there. All right, here's week 1 also. Most common reasons for accidents to happen. Go over that. I will ask you questions when it comes to this on some of the tests. All right. And over here, it's already available for you to look and download. Here's the multimeters part 1. Now, the part 2 is still kind of not highlighted. You can't get added right now because it's not posted yet. And there's a date that it's going to be available for you to view or download. Okay? It's not the same time and date as the class starts. All right, so these are your posted lecture notes that you should look at and study. Now, I'm just going to collapse that folder and I'm going to click on the labs. Here's the first lab, here's the second lab, and I'm going to populate with this thing. I just have this thing here. So now you can see this, you cannot see the other ones yet. And I'm going to add lab 3, 4, 5. As I'm still working on I'm tweaking the details. So this is going to be populated. Now, if you click on this here, lab 1, That's the lab. These are the tools that you need to bring for the lab, aside from the personal protective equipment. And I'm not allowed to have you in class if you don't have the boots, the proper safety boots, hard hat, and safety glasses. I'm not allowed to have you in that class. Right? Now, wire strippers, needle nose pliers, and basic screwdrivers according to the tool list from the week one. So look at that. And side cutters, that's what basically we're going to use in the class. Bring those tools, please. Now, this duplex receptacle and the piece of wire, or the length of wire, should I say, it is going to be provided in class for you. And of course, here is the explanation of step by step of what we should do to perform this lab. I will give you a short demo, and I will be working with you in person in order to accomplish the activity. All right, so that's pretty much it as far as now. Here's my information. If you need to contact me, please, by all means, send me an email if you have any questions, or talk to me in person. All right, so let's go and start with the multimeters, because we only have so much time to complete this class. So I'm going to call up my PowerPoint, and this here, the PDF version of all the slides, are basically what's in the posted lecture notes. All right. Here is our first slide. Title of the class: Multimeters and Other Circuit Testing Devices. Part 1. I've thrown in some pictures of different types of diagnostic devices and some multimeters. Right? So this one here, this type of diagnostic device is a data circuit tester. It will test Cat5e cables or coaxial cables for various components that need to be tested. We will use that in the second semester. So this is a type of multimeter. However, it's not the type of multimeter that you will be using for the most part in your electronics or electrical type of testing. Okay? Now, by the way, I'm just going to mention, I can see the chat line here. Someone has some questions, just pop it in the chat lines. Or if you wish, you can also pipe in with voice. Just make sure you unmute your microphone if you want to ask me a question. All right. All right, so here is a little bit more complicated diagnostic device, and these two here, this one and that one, these are so-called clamp-on meters, and I'll show you how to use them once we get to the labs. The clamp-on basically is used for measuring current, and it also has a couple of ports that you can measure other quantities, such as, zoom in, such as voltage, AC and DC. You can have this thing as a resistance meter or as ohm meter, current, AC. But when you switch on that, you use the clamp on. For everything else, you use the ports. So if you want to measure voltage, you use those leads, you plug them into these ports, and you use it just like a regular multimeter. Okay. All right. And there's, for the most part, the one that you have purchased in I think you have it in your kit. It is this type of a multimeter, which we're going to concentrate on in the next few slides. If I can switch the slides. All right, let's start with the definition of what multimeter is. And just, I'm going to mention this thing once in the first class. Sometimes what I will do is I will post the text and I will read the text as it is posted. And my reasoning for that is that if I post a text and I talk over that, you will try to read and try to hear what I'm saying, and you will get none of that. All right. So sometimes I will read it, and sometimes I will stop in the middle of the sentence to explain certain concept or two. Right? So that's my style of teaching. That's the reasoning why I do this. So first bullet point right here. What do we have? A multimeter is a device used to measure voltage, resistance, and current in electronics and electrical equipment. Well, not much to explain here. All right, let's see the second bullet point, what hides in there. Using certain multimeters models, so using certain multimeter models, you can test to be sure that the components such as diodes, capacitors, or transistors function properly. Some of the multimeters have that function as well. You can also troubleshoot your circuit to see where the current is failing and pinpoint the problem spots depending on what type of equipment you're troubleshooting and what type of a failure you're looking for. A multimeter can be a very helpful thing. In fact, it could make your job possible at all. Right? And it is also used, a multimeter is also used to test continuity between 2 points to verify if there are any breaks in the circuit or line. Well, as we go along, we're going to tackle these aspects here. Okay, and these concepts will be explained tomorrow when I see you in person during the second part of this presentation. All right, advanced models are capable of graphing and printing waveforms and other diagnostic tests. And of course, if you're capable of graphing and printing, some of the multimeters or diagnostic equipment can also save the data that was produced by the test into a memory, which can be printed or analyzed or sent to the client if that's what the client wishes. All right, two basic types of multimeters. Now, it's going to be 2 and 2. So first, I'm going to take a look at two basic styles of multimeters, period. Okay. Then in the next few slides, we're going to look at the two different styles of digital multimeters. But here, let's get the overall styles of multimeters. Two types. Analog, which looks like this, and digital, which looks like this. Right? Now, what did I write here? The value of the measured quantity in analog. The value of the measured quantity is displayed by deflecting a mechanical pointer against the analog scale. And that's what the pointer is. Here's the needle, and here's the analog scale. Cool. All right. Now, in digital, the value of the measured quantity is displayed on a digital readout, which is right here, mostly LCD. And I said, see the next slide for other types of display examples. There are different types: LCD, LED, OLED, AMOLED, LED, Right? That's for your own reference. I might ask a question or two about that on the test, but our tests are open book tests, so sometimes I make you look for the answers. All right, so now sometimes, for the most part, you can measure. Sometimes, for the most part, you can measure whatever you need to measure with the digital multimeter. There are certain situations that digital multimeter is not going to do the job because you need to see the needle. You need to see how this thing behaves. Let's say if the voltage here is AC and whatever the value is displayed, and this one apparently displays almost 4,000 volts, right? But look at this thing here. The range is selected for 100 volts. So whenever the picture was taken, somebody forgot to include the dot. 399.9 volts. Because the range is selected 400 volts, that means you can't, when this thing is selected to the 400 volts, it becomes a voltmeter that can measure voltage of up to 400 volts. AC in this case, because that's where it's selected here. If the voltage measured is bigger than what the range is selected, you're just not going to get a reading. It's going to say error or some kind of a overload or whatever symbol is going to be displayed. Now, if this thing stays there, if the value stays there at that level, sure, digital multimeter, no problem. But what if you want to see some variations of that? So the needle is going to deflect so much, and you can see that the voltage is somewhere here, but it pulsates, hovers like that. The needle is going to show you that. This one here won't. It's just going to start trying to count up and count down, count up and count down, and you're not going to be able to figure out where it goes on the top and where it goes on the bottom, and it's just going to see a bunch of numbers flashing. It's going to look like this thing is going crazy. Right? This one here, you can see it goes up to here and it hovers like this. Okay, it just deflects, pulsates or something like that, right? So that's why sometimes you might want to use the analog versus digital, although the digitals are newer than that analog. Okay. All right, let's see what next slide hides. Okay, that's the one with the different displays. I'm not going to go over that. But I encourage you, maybe even I would just say that maybe I have ignited some sort of curiosity in you that you can actually check what those different displays are. It's a valuable knowledge for you to have if you're in this type of technical field that we are here now. Now, there are two different types of digital multimeters. So first we looked at the types of meters overall. Now we're going to look at two types of digital multimeters. One is a switched range and the other one is auto range. All right, differences. This is what a switched range looks like, and this is what an auto range looks like. Now, when I zoom in, I'm going to take a look at the auto range first. All right. So you have applied your leads into appropriate ports. So for example, you want to measure AC voltage. Okay, so you would have the black lead common, the black lead plugged into the common port. And where do we see voltages? Oh, here, look at that. So if you want to measure voltage, you use this port. So your red lead is going to go to this port here. So these two ports are going to be activated when this meter is switched to AC voltages. Now, I'm going to explain to you what most accurate reading is on the multimeter during the second part when we see each other in person. But what I'm going to say is that in this auto range, you just switch the dial into measuring AC voltage, and the range that is selected is going to happen automatically. Same with the DC volts, millivolts here, ohms, capacitance, amps, and microamps. And this one actually can also measure temperature. Now, it's just like driving an automatic transmission car. You put it in drive, and it's going to automatically switch the gears. Now, here's just like driving the standard stick shift car. You will select the quantities, like for example, AC volts. Now, somewhere here, there should be another divider marked, but it's not. So this is a little bit confusing on this one here. But usually we're going to have a clear understanding of where one quantity stops and the other quantity begins, like voltage or current. So let's say here, this one here is switched to AC voltage. My mouse keeps disappearing. AC voltage. And because it's switched right onto the 600, which means it makes this multimeter a voltmeter that is capable of or set up to measure AC voltage of up to 600 volts. No more. If it's more than 600 volts, this meter won't be able to measure that. Now, if you switch the range to this 200 number here, then it becomes a meter that is capable of measuring voltages of up to 200 volts. Now, when it comes to, and this is the purpose of that is for you to obtain the most accurate reading. The point, the decimal point is actually going to move while you switch the ranges. So if you measure something like 195 volts, you could measure this thing when you select the to 600 volts because 195 volts is within 600 and it's going to give you some number, but it's not going to give you as accurate number as if you switch it to 200 volts. Then the decimal point is going to move. It's going to give you a little bit more accurate reading. So that's for now. That's the switched range. You automatically switch the ranges. You control this whole thing. Over here, the range, one of those, internally is going to be automatically selected by the voltmeter to give you the most accurate reading, depending on what the voltage is. Now, it's a matter of preference. Some people prefer the switched range meters. Some people prefer the auto range meters. As far as I am concerned, I prefer the switched range because that gives me more control of how actually I'm using this multimeter. However, these have become pretty good within themselves to give you some accurate readings, just as accurate, pretty much. It's a matter of preference. Okay. Zoom out. So here's the switched range multimeter, the two types of digital meters, switched range and auto range multimeter. Okay. Whoa. Next, okay, so this is basically an explanation of what I just said, so I'm not going to read this one right now. You can read that. For most accurate reading, elaborate, and we explained and we elaborated on that. We're going to elaborate on that a little bit further when we see each other in person in class. Now here, measurement categories for the meters. Okay, now I'm going to stop and say something. You just because you see this as cat 4, cat 3, cat 2, that's a very similar terminology when we use for data cabling. You have heard pretty much somewhere at some point somebody says, is this cat 5 cable or is it cat 5e cable or is it cat 6 cable? That refers to the data cabling. And the categories have to do with the specifications of what type of signal it can actually handle. I'm talking about the cable. This has nothing to do with that. These categories are completely, they deal with completely something else. When we're talking about the multimeters and categories of the meters, they have to do with the severity of the measured quantity. Severity, I mean by how much damage it can actually cause when something goes wrong. Now, I've listed here category 2 and category 3 and category 4 of the measurement times and the categorized multimeters that have to go with that accordingly. I did not list category 1 because category 1 deals with measuring things that are not powered. Like, for example, if you want to measure resistance of a resistor, the resistor is not powered. You're just measuring the resistance of it. It's out of the circuit. So I'm just, with here, I just want to concentrate on things that are powered that you're measuring. Category 2 is the lowest. Category 4 is the highest and most severe. This is the less severe. All right. So let's take a look at this thing here. Category 2 sources. Where can we see on the picture category? Here's category 2, nowhere else pretty much. And here's category 2, nowhere else pretty much in the household wiring or commercial type of wiring. So category 2 would be what? A single phase receptacle connected to loads. Well, the electrical panel is considered to be a power supply connected to the receptacle that you can actually get the power out of. And if you plug in a refrigerator to it, then the refrigerator becomes the load to the power supply. So that's what I mean by loads. Or TV. TV is a load onto the circuitry here. Now, so you could use the category 2 meter to measure anything that's voltage or current that has to do with these type of devices that are plugged into this type of receptacles. Let's elaborate on that. Move along the table. This would be appliances, portable tools, and other household and similar loads. You can use the multimeter on those loads that are plugged into this. I'm just going to wait for the phone to stop ringing. And it did. Oh, not yet. Okay. Someone pick it up, please. Okay. Now, category 2, single phase receptacles, as opposed to 3-phase, or maybe, so. Okay. That's the beauty of online teaching, right? All right. So the appliance, single phase, well, this power supply as far as the electrical panel could have 2 phases. But this here, this receptacle, this duplex receptacle, we're only going to have 1 phase for the most part. Okay. Now, these also include the outlets. There is more elaboration, more explanation on what this thing is. Outlets that are more than 10 meters or 30 feet from the Cat3 source. What's a Cat3 source? Cat3 source would be the electrical panel or the distribution panel. That's a Cat3 source. Do not approach that with the Cat2 type of a meter. Now, if the receptacle is closer than 10 meters, it becomes a short branch as opposed to the long branch circuits. Now, the short or long branch are different than short or long, sorry, there's no long circuit, short circuit or open circuit. I have a little thing here. Now, when we have a circuit here, here's a power supply, and this is a DC power supply because you can see the symbol for a DC power supply, and the longer line here serves as plus, shorter line says as the negative side of the DC power supply. And of course, we're going to have current flow this way. If we're talking about conventional current flow, the current is going to flow through the resistor, which is the load in this case, and it's going to come back to the power supply. Now, if we just connect somewhere along this, these are the 2 wires, and if we break those wires and drop a kitchen knife across those wires that are bare, we're going to short the circuit right here. So now the circuit is shorted. The power is not going to the resistor because it's all going to go here. And because there is no resistance, there is no load here, it can put this power supply into overload situation, which can, well, it can actually blow up. So that's a short circuit. There is no such thing as long circuit. As opposed to short circuit, we can have something that's called a open circuit. If you break one of those wires, you can put a switch there. Close the circuit and open circuit, close, open circuit. So closed and open circuit. Now we're having a short or long branches. So the long is not opposing the shorts. It's a completely different concept. I just want you to be able to distinguish between those two. Right? So long branch it gets further away from the source, which is the electrical panel, and shorter it gets shorter, which is the distance between the wire is shorter. And there's some specifications here: 10 meters, 20 meters, Cat 4, Cat 3. Now, with Cat 2 meter, you can measure the appliances of a Cat 2 source, which is a Cat 2 source, outlets and long branch circuits, which are further than 10 meters or 30 feet from the Cat 3 source. You can use Cat 2 meter. Or 20 meters or 60 feet from the Cat 4 source. Where do we have Cat 4 source? Oh, here's one. Here's one. Notice the Cat 4 source is just outside. Whatever is outside, Cat 4 source. All right, let's take a look at Cat 3 sources or measuring equipment. Three-phase distribution, including single-phase commercial lighting. So here's a commercial situation here. Here's a Cat 4 source. It's outside. Now the buried cable also be because it's outside, it's buried. It's not within the building. It's also considered a Cat 4 source. Once we are inside, we're becoming Cat 3. So here's the distribution panel, also known as electrical panel. Here's maybe a transformer. Here, electrical transformer of fixed installation of whatever kind. That's Cat 3. So here is Cat 2. Look at that here. That's what applies here. Cat 2 sources. So there, Cat 3, which would be here, 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 electrical panel, or in the commercial circuitry associated with the electrical panel here, which in case could be a transformer. Okay, this would include that you can measure with Cat 3 type of a meter, equipment in fixed installations such as switchgear and polyphasor motors. There could be some motors there, bus and feeder industrial plants. You'll probably talk about that thing in the next classes after me. Distribution panel devices, lighting systems in large buildings, appliance outlets with short connections to the service entrance, short or long. Here is what I mean, okay? Is what this means. So that'll be Cat 3 power source, which should be approached with no less than Cat 3 type of a meter. Now, Cat 4, three-phase at utility connection, any outdoor connection. So if it's a three-phase, it's Cat 4, or if it's anything that's outside, it's also Cat 4. If it's a three-phase meter power supply inside the building, that will be considered a Class 4 circuit. All right. Now, so that meter that you have, let's see what it is. This is the meter that you have, or very similar to this one. There should be some information on that. And at the back, if you look at this nominal kind of a plate, if you can call it that way, I just took a picture and magnified this part of it. And if you magnify it, that's what it says. This meter, as far as categories are concerned, it can measure up to 600 volts while dealing with Cat 3 source. And you can also measure up to 1,000 volts if you are dealing with category 2 source. And these are the category 3 sources, category 2 sources. Okay? And now you know a little bit more. All right, types of meters. Meters can be simple and meters can be complex. Let's go look at the simple meters. This is a simple, what kind of range? Will be switch range or auto range? This is an auto range. Look, this just shows voltages or ohms. This is voltage right here. Can I zoom in? There's a little bit of a volt symbol here. And you can use resistance, you can use diode, tester, It's the range will be switching. Or sometimes you can switch the ranges on using these buttons, depending on what the model of there are many different models of multimeters. So what I would say, always read the manual so you can get the full benefit of the equipment that you're using and how things are being solved and approached and designed for using that multimeter. And then the second reason of reading the manual is so you are not going to do things that you're not supposed to do with this particular meter. Everything has its own little rules that things go by. Here's another example of simple meter here. Of course, for this one here, I'll probably have to read a certain short type of a manual of how to use this particular meter. It looks to me, maybe it looks like more complicated. A simple thing make more complicated than it needs to be, but there are meters like that as well. And there's another simple meter. It's a clamp-on meter. Here's a lever or lever. When you press that physically, this clamp opens. Here's the opening of the. Oh, what happened here? I just lost. Okay. All right. Something happened to my display. Can everybody hear me and see me? And you should see the PowerPoint here presentation.
Yes.
Okay, good.
Yes.
Thank you. Thank you. Thank you. All right. I'm just going to go. Can I do this? There we go. Here's we're back online. See? The clamp on meter, and then you can clamp it onto a single conductor, and it's going to sense the magnetic field around the conductor and display the current that flows through that conductor. So it's like a non-invasive measuring of the current. And of course, you also have the ports here that you can use to plug in the leads, and you can select different like voltage or resistance. You can also use that as a regular multimeter. Right? Now, meters can be complex, and sometimes they're so complex that they actually come with a 1-800 telephone number for you to call to make sure that you know how to use that particular multimeter. One of the examples would be, well, there could be an expensive DSL type of a meter, or you can also measure T1 or DSL type of a feed with that, and that can cost like $20,000. And once I had to use that, and I had to call in the number just to be able to turn it on properly and set it up for the measurement that I needed to do. Okay, so you still have to know your stuff as far as what you're looking for, what you're measuring, but the 800 number, tech support number, is there for you to, so you don't have to learn the whole piece of equipment, and some of them are complex, if you just have to use it once, right? That type of stuff. And because it's some of the equipment is more expensive, then you don't buy it, you just rent it if you need it if you need to use this thing just once. All right. So they can be simple and they can be complex. Okay, this is the last slide. Last slide. Meter leads. Ports. We have ports on the meters. For the most part, they're going to look like this. There's going to be one common, and look, this is kind of tinted black, and this is tinted red. All right, so let's see, what do I need to do if I want to measure voltage? Okay, I'm going to have one common lead, so that has to be plugged in, and that's where the black lead goes. And where do I plug in the red lead? I want to measure voltage. Oh, there's a symbol of volts here. So it's going to be this port. So if I want to measure voltage, I'm going to use these ports. Those plugs go right here and here. Cool. And then you select the appropriate range, voltage, DC or AC that you're measuring, and Bob's your uncle. There you go. You can measure the voltage. And this one here, you can actually select the range. You can toggle between ranges manually, or you can use auto range. Pretty cool. So this, so aside from auto range or switched range, this one is both. You can use it as just like those cars that you can switch to manual or automatic. Right? Cool. Where are we here? Ports. Now the other ports, if you want to use, because this is sort of auto range meter. If you want to measure current, you will plug in the black lead to common, again, same thing, but depending on the severity of the current. So if it's within the milliamps, 20 milliamps, 50 milliamps or whatnot, or microamps, small currents, you would use these two ports, and this port will be fused internally inside. You should be able to take your meter apart and know how to replace the fuse. So that we would use these two leads. And you see here, there's additional information. It says, with these ports, you can measure up to 400 milliamps, and it's fused. If the current is more than 400 milliamps, poof, the fuse is going to go, just so you don't damage the rest of the meter. And if you want to measure amps, 1 amp, 2 amps, 5 amps, oh, this one goes up to 10 amps, and it's also fused, and it has another fuse that can go up to 10 amps, and if the current is bigger than that, the fuse is going to let go, just so you don't damage the next. Now, so that's why some of the printed circuit boards and the internal circuitry is designed to handle certain type of severity of the voltages and currents that you're going to measure. And it's assigned to the category 2, 3, and 4. If you have a category 4 type of source and you're trying to do the measurements with category 3 or 2 meter, there could be a high risk of you to actually get injured, because the circuitry might not handle those quantities and the type of power that goes through it. And if something goes wrong, it goes wrong very quickly, and you could have pretty much like an explosion in your hands. Right, so it can blow up in your face, and I don't know about you, but I like my face. So there you go. Now, anatomy of the probes. Here's the probe. Here's the tip of the probe. Here's the lead, and here's the plug. And you have the red and black probe. Some of the multimeters, I think yours has that capability, that they come with a little attachment that you plug in here, and you can test the transistor for the HFE, which is the amplification factor. All right, or coefficient. All right, so and you can also plug in you also, I believe you also have a temperature probe in there, but it will show where to plug those things in, okay, as when you're reading the manual. So red meter lead, black meter lead, that's where they get plugged in, and these are the descriptions of things that I just basically said. Now, displays and the settings, anatomy of the meter. Well, here's a digital display, or it could be analog display when you're dealing with the analog meter. Here's a meter dial. With this dial, you select things on the panel indicator, whether you want this thing to be voltmeter or amp meter or ohm meter or you want to measure other quantities. As I said in the class before, the pretty much basic difference between a multimeter and a hammer is that you can do more than one thing with the multimeter. With hammer, you just hit things. Okay, maybe two things. You remove nails. Right? Well, maybe you can use it as a boat anchor as well. But here is the meter dial. You set things on that, and you also um, you can use other things. That depends on how the meter is made. But this will be the basic dials here, and you have the probe ports. So that's as far as a basic anatomy of any kind of a meter. It could also be dressed up as some with some additional functions depending on how this thing is made. Okay. And this was the last slide. So we're going to continue with some little bit more details on how to use the multimeters. And the second part, which is going to be tomorrow, and it's going to be in person. Okay, guys. Thank you very much for your attention, and I'll see you when I see you during the in-person class. Thank you. Hmm. This thing flashes so quickly, I can't. There it is. Oh no, it disappeared on me. Mr. Zoom, how did you do this thing?